Hello there, welcome back. Today we are going to be looking at volume with triple integrals, where we're going to look primarily at using cylindrical coordinates. Now, cylindrical coordinates are very similar to our polars that we talked about earlier, but whereas polars are two-dimensional, cylindrical coordinates are going to give us like a three-dimensional version of a polar equation. We're going to be using primarily circular bases, and we're going to find out very quickly why we like circular bases and cylindrical coordinates. So in order to evaluate the volume of a figure in cylindrical coordinates, we'll use our previous results from polars from double integrals. And that's what we just kind of talked about here. Remember, in cylindrical coordinates, we're going to use the following. The conversions. X is always going to be r cosine theta, y is equal to r sine theta, and x squared plus y squared equals r squared. This is why we like circular bases. So these are our polar conversions from earlier. But notice, none of these have a z coordinate because polars deal with a flat surface. It deals with only the xy plane. So if I'm looking in three dimensions, x, y, and z, I'm only looking at the part on the xy plane. To give it the height, we're still going to let z just be z. So the integral, that we will want to evaluate to find the volume is derived from our previous result, and is this: dv equals r dz dr d theta. Now, in rectangular coordinates, dv was dx, or dz, dy, dx, and we talked about how we can arrange them. So our integral that we're going to evaluate is we're going to convert it to this. So here is our rectangular coordinates, right here. Here is our rectangular. Take a look here, where our dv, our change in volume, is going to be dz, dy, dx. And our function is in terms of x, y, and z. To convert it to rectangular, we have all of this right here. That looks really messy. This looks really messy right here, but all this is saying is to convert to polar. That's all that really says right there. Convert to polar. Don't forget we have our r, dz, dr, d theta. Are three variables. So what is this really trying to find the volume of? Well, if you ignore the function part, if we only want to look at this part, well, what is this really the equation? What do we really find the volume of? So this is a cylinder. So let's talk about how do I know that this is a cylinder? Well, one, I'm dealing with circular bases. So if I draw a circular base and I add some height to it, like we did last year, this is my little change in height right there. That's our delta z right here. Going outwards, there's my radius. And we're going to spin our radius around the circle and get theta. So if we change r, increase r, spin around, and we increase our z as we're doing that, we're going to get a cylinder. Remember, all of these are changing kind of at the same time. So radius is increasing as we're spinning around, and the height's increasing, and that's going to give us a cylinder. So how do we get this equation right here? Well, we know that we can say that volume, and we talked about this earlier. If I want to find the volume, I look at the area of the base, which is our circle, which earlier we said was our arc length, S, times delta r. You can look at a previous video that where we talked about this. There's our arc length, S, times the change in r, and to get the volume, we just multiply that by delta z. Well, again, in another video, we said our arc length we could write down as r delta theta, and this stays delta r delta z. And this is how we get our volume. Of course, we let all of these go to 0, and we get our volume right there. All right, so that's kind of just a quick thing to kind of go over this. So let's take a look at some examples. We want to evaluate the volume of the figure below the plane z equals x plus 2 from above and above, the XY plane. So we're looking at only above the XY plane, but below here. So we're going to find the volume above the XY plane, but below our plane right here. And we're going to be between the cylinders. X squared plus y squared is 1, and x squared plus y squared is 4. So they're giving us here the base. And over here, they're giving us the height. So I have my base, I have my height. Multiply those together, we get our volume, and that's what we're going to be looking at here. So if I start with my base, the first one has a radius of 1. That's pretty easy to do. Our second one has a radius of 2. I can draw that too, not drawing the scale. And we're looking at the area between here. Okay? Donuts. So this is my base, remember, and this is going to be projected to the surface. Z equals x plus 2. We're going to project it to the surface and find that resulting volume. So we could write this in rectangular, but we want to try to do this in cylindrical form. So to do that, we have to think polars. I can think polars. Now, another way to think polars, I want to know how r and theta change, the radius and the angle change. That's what I'm going to be thinking about. How does r and theta change here? Well, I know that my radius, it starts at 1. I only want the shaded region, so my minimum radius is going to be 1. My maximum radius is going to be 2. So my radius is going to go from 1 to 2. Theta, well, we want to go all the way around the circle, so theta is going to change from 0 to pi. To 2 pi, all the way around the circle, 2 pi. Now, this is our base area. To get the height, that's our change in z. Well, I know that the change in z starts at the xy plane, and on the xy plane, z is 0. So I'm starting at the bottom, and I'm ending up at z equals x plus 2. So it's going to go from 0 to x plus 2. But here's the problem. Polar, rectangular. We have to convert to polar or cylindrical. So we're going to convert that. So to do this, I would now get 0. My x, I know is r cosine theta plus 2. I know that because of my old conversion factors from pre-cal so many years ago. And there is our change in z. So my integral now I can go and write out my integral, my volume, space it out. Remember, we're going to get a lot of writing here. Okay, we're going to get, now on the inside, this is my volume, so it's going to be, remember, r dz dr d theta. That's the order I want to go. R dz, so my change in z goes from 0 to r cosine theta plus 2. My change in r goes from 1 to 2, and my change in theta goes from 0 to 2 pi. And this will solve us our integral. So let's go ahead and solve this just for fun. Why not? Got nothing better to do, right? So if I solve this, this becomes the integral of, this just becomes r squared. Now this is not too hard to do, so I could probably go to the next step. From 1 to 2, this is r squared, which is going to become, if I square here, forget, we're integrating with respect to z. Sorry about that. Not r. We're going to integrate with respect to z first. And since there is no z here, this is just going to become r times z if we would integrate it, and z is going to go from f of b minus f of a, so we get r cosine theta plus 2, and this just stays dr. Integrating here, we might have to do a little bit more math. This is r squared, so we're going to get r cubed over 3 cosine theta plus 2r from 1 to 2. Simplifying this, we get 8 over 3 cosine theta plus 4 minus 1/3 cosine theta, be careful and distribute, And some of you guys probably noticed, but when I distributed my r, I forgot to put it here, so this is just really r squared there. So that's going to be still 4, but when I plug in the 1, we get minus 1 right there. Sorry for that. And if you simplify this, we're going to get 7/3 cosine theta plus 3 d theta. That's what I get for like skipping steps. And this one we're going to integrate from 0 to 2 pi. Now we're integrating with respect to theta now, so this becomes 7/3 sine theta plus 3 theta from 0 to 2 pi. And when you solve all of this, you're just going to wind up with 6 pi. And there's our answer. Alright, so sorry for a couple of errors right there. We did correct them though. Number one, mistakes, you're going to make mistakes. Just don't be afraid to fix them, okay? Because remember, this becomes 2r or 2r squared over 2, and those canceled out there. Alright, hope you enjoyed the video. I will come back to part 2. We'll take a look at another example.